Okay, so let's look at number 11, section 1.2. So if I can figure out the new settings here. 11, section 1.2, we have a sphere. Okay, so that sphere is going to be growing or getting bigger, and it's going to stay a sphere. And it says that basically we have r centimeters, so there's r, the radius of the sphere. So if we have r centimeters is the radius, and a of r is the surface area of this, then the surface area of a sphere is 4 pi r squared square centimeters. So that's the surface area of a sphere. Now, where does that come from? That comes from calculus. We can potentially prove that later in the course. But anyway, so what we're going to see here is that a balloon maintains its shape of a sphere as it's being inflated so that the radius is changing at a constant rate of 3 centimeters per second. Okay, so if the radius at time t is going to be f of t, so it's a function of time, we need to figure out what that function of time is. So one thing that we could do is get a relationship. So if we have t seconds, we want to know what f of t, which is the radius at time t. So f of t is actually equal to r. So if that's the case, if r equals f of t, then we can take f of t and plug it in here for r. And so that becomes equivalent to 4 pi f of t quantity squared, square centimeters, right? But anyway, so let's just start with something easy. If we have time 0 and we're assuming that there is no sphere, right? But after 1 second, it's going to be 3 centimeters. After 2 seconds, it's going to be 6 centimeters, etc. So it's going to continue to increase at 3 centimeters per second. So each second bigger, we're going to have three more. So if I just said time t, what would time t be? What am I doing to get from 0 to 0 or from 1 to 3 or from 2 to 6? I'm going to take 3 times it, right? So t 3 times t. So basically f of t is going to be 3t. Okay, so if that makes sense, then that's what we have as a constant rate of change. So then I can take that and I can plug that in right here. And so really what it says here is A composed with F, so that's a little circle. A composed with F evaluated at T is A evaluated at F of T. So really what we're doing is we're plugging in F of T instead of R. So this is going to equal 4 pi times 3t quantity squared, right? Square centimeters. So then if I square the 3t, that's 9t squared. So it's 4 pi times 9t squared. And of course, we can combine like terms. 4 times 9 is 36. Pi is the constant. And then t squared, centimeters squared, is going to be the surface area in terms of time t. So this was the surface area in terms of the radius, but this is down here, this is the surface area in time, in terms of time t. So it's A evaluated at f of t. So the radius is actually a function of time. So we could consider this as a composition of functions, correct? So then, if I can clear that off, and then I got to go back to where I can write it again. So anyway, so then it says, hey, what would for part B here, if I can get it to be a drawing. So for part B, it says, hey, what's the surface area of the balloon after 4 seconds? So we're looking for A composed with F evaluated at 4 seconds, which once again, it's A evaluated at F of 4 seconds. But once again, we have A of F of T, A composed with F evaluated at T in general, we already said was 36 pi T squared. And once again, that's going to be square centimeters. So A composed with F of 4 is going to actually equal what? We're just going to plug in the 36 pi, and instead of t, we have 4 squared. So we have 4 squared is 16. So this is 16 times 36 pi, right? So just multiply that out, and what's that? It's 36 times 16. Basically, I could double it 4 times because 2 to the 4th power is 16. So 36, so 72, 144, 288, and that would be 500, I believe. 288 times 2, 500 plus 38 times 2 is 76. So 576 pi square centimeters. Okay. Now, this is the answer that I like because it's exact. The book also has approximately equal to whatever 3.14159, et cetera, times 576. You could round it to 1 decimal place. So somewhere around 1810 or something like that, approximately square centimeters. But once again, this is the answer that I like for this. This is exact. So once again, we're just considering the composition of functions for the surface area of a sphere here.